Well, good morning, or good afternoon, I'll start. My name is Maureen Hager. We are thrilled to be with you guys virtually. So I work for an organization called STEM Forward. So we are a nonprofit in Milwaukee, and we work with K through 12 students and professionals like we've got today to really just try to hopefully inspire you to go into some sort of STEM career or a STEM field. But we're really excited today. We've got 3 representatives from RSI, so I'm going to give them an opportunity to introduce themselves, and then we're going to jump right in. Do you want to go ahead and start maybe, Cody?
Yeah, so my name is Cody Lewis. I am a full stack software developer. Been doing it for about 6 years in a myriad of industries and technologies, and based out of the Milwaukee area.
Go next.
Go ahead,
Todd Schmidt. I'm also a full stack developer. I've been developing for a long time. We'll kind of get into our backgrounds a little deeper. But yeah, I do a lot of front end and back end development.
My name is Alfredo Liu Perez. I am also at RSI with Cody and Todd. I've been programming for more than 20 years. Maybe 30 if you count before college. I do a little bit of everything, front end, back end. I also do some mobile apps development, and most of those are on my own, but I did one for a client once.
Got it. Okay, and let's just check in. So Tom, how are you doing with everything, the audio and visual? And
pretty good. I was just trying to figure out if we can do closed captioning, but I don't see that control. I have a few deaf students, and I didn't think about that, unfortunately, but it looks like it's a possibility, but I don't know how to turn it on. Anybody?
I don't know if RSI has to do that since they initiated the Zoom.
Yeah. I don't know if one of us was given proxy host abilities.
I don't see the ability here, but I know it's doable in Zoom.
I'm going to reach out to Ian for help.
Oh, thanks, Todd. Yeah, if you don't mind.
Yeah, I appreciate that. I apologize. I didn't anticipate that.
And while we're waiting, about how many students are in the room with you, Tom, just so we have an idea?
There's about 30 students in here.
Okay, great.
Captions. We had some developers that were actually had vision problems. So, and I know there was also a graphics designer that had some hearing impairment at a different place. So these are careers that are open to everybody. The person with the visual impairment, he has a special equipment, so he can see the screen super close, and he can also replay it back the text. And they get really good at the speed. So I don't even understand what's happening. He's going, but he knows what's going on.
Huh.
Did you hear back yet, Todd, from Ian, or should we? Okay.
I have not, unfortunately.
We do have an interpreter, 2 interpreters here actually. So I think we can continue if it's not, going to happen quickly. We don't want to like slow up the process.
Okay, sounds good. Why don't we go ahead then get started? Also, those students at the end, if they wanted to submit some questions to you, Tom, we could always follow up with some answers, things like that as well.
Yeah, for sure.
Okay, great. Well, go ahead and I'll turn it over to the RSI team.
Yeah, so just to start off, if there's going to be a Q&A section at the end, but if anybody has questions throughout, we definitely welcome that, and feel free to interrupt us for any questions that or clarifications that might be helpful. And the 3 of us are going to go through our introductions in terms of like how we got into the position we are today, and anything else that's relevant along the way. So I will start off. My name's Cody again, and my path to being a software developer is a little bit unconventional. I didn't really know what I wanted to do in high school. If a class like this existed, I definitely would have enrolled and it would have been very insightful. But when I was in high school, I played a lot of video games and kind of just got by. I was smart enough to not really have to study. And that was sometimes to my detriment because I didn't really put a lot of effort into things. So post high school, I took some college courses and got a 2-year degree, but I was kind of meandering through life and didn't really know what I was doing. I was waiting tables, which I was having a great time doing, but I was like, I don't really know what I want to do for the rest of my life. So I actually had a breakup with my girlfriend at the time, which spurred me to take a 3-month trip to Japan to work on farms because I thought maybe I could figure out my life when I was doing that. And over the course of weed whacking one day, I was like, if I don't figure out what I'm going to do with my life, this is what it's going to become. Not working at a farm, because there's nothing wrong with that. It's just more so I'm going to be doing something that I'm not going to enjoy for 8 hours or more a day and just kind of lost. So my trip that initially was going to be 3 months turned into 3 weeks. There were only a couple days on the farm, and I came back early with the intention to become a programmer. So before my trip to Japan, I had dabbled a little bit in self-taught courses online. And when I came back, I just became a hermit. For 3 months straight, I was completely self-taught through online courses, learning JavaScript, HTML, and CSS. My friend, who was also kind of my mentor during this because they got a degree at SMU, which is a college in Texas for computer science, was actually the owner of his own company. And he was lucky enough to give me an internship. And that started out with the basics of the technology, as I mentioned before. And eventually that turned into a full-time job. And from there, it transitioned into more of working in the back end with PHP was the technology at the time. And life eventually took me from Texas to Wisconsin. And after going to some local meetups is where I found the current job at RSI. And my journey is different because I didn't go the traditional path. And I really like that for me because it really speaks to the industry of software development because it's continuous learning. And if you have the want to learn things on an ongoing basis and you're not deterred by those opportunities, it's something that really is exciting to pick up new things along the way. And that's what got me where I am today.
Okay, I can go next. I'll give a little bit of my background. So I first started programming back in about 1994 when I was in 7th grade, which is like forever ago now. I had an Apple IIe computer, which is like one of the early computers put out by Apple that was successful. And that's like you boot it up and you just see characters on the screen and nothing else. There's no folders, drag and drop kind of thing. So it's pretty primitive. And I would make programs that I would read in a book and then be like, oh, this is how you do it and that kind of thing. So I was programming before the internet, and things are, I think, a lot different now and easier for people to start to program. But even though I had like that early experience with computers, I ended up in high school. I took all the electronics courses that I could. We had like 3 or 4 electronics courses that you could take, and I built all the projects, and I thought I was going to go to college for electrical engineering and not programming. So that's what I did. I went to UW-Platteville, which is in the southwest corner of Wisconsin, for college, and started in electrical engineering. After about 2 years, I did not like that. I wasn't feeling like I was good enough at math. We'll talk about that a little bit later. But also the way that the electrical engineering program was, it was like, here's all the theory, read this book, solve these circuits kind of thing. I describe it as maybe like more like old school engineering teaching, and computer science was more programs and projects. So I would just go down to the lab, maybe like I build a thing and I learn some stuff while I build the thing, and it was a lot more interactive. So I enjoyed that a lot more. So after 2 years, I switched majors, had to redo some classes basically from switching. Got my degree. I got my first programming job. I was testing code for helicopter safety systems and stuff. And so it was working in sort of an interesting industry. And then later on in my career, I kind of had to make a switch over to web programming. So I had to kind of relearn stuff. Like I didn't use HTML when I was working on helicopters. So I kind of had retrained myself. And now here I am at Rural Sourcing, making web pages for people every day.
I grew up in Central America. As you can notice from my accent, I wasn't born here. That was in the 80s. In high school, we had a computer class actually with Apple IIes. We didn't go to class too much. There weren't too many computers for all the students, so most of the class was on the blackboard. But I really loved it. My parents bought us a Atari 800, and my brother and I learned to program BASIC and assembly for the 6502. Those were really old chips at the time. I don't know why we got the assembly. I don't know. For some reason, we thought it will help us learn to program. And we did learn to program BASIC and assembly. My brother is actually better programmer than I am, but he's not into computers. He went to a different field. I went to college for electrical engineering, like Todd. So my journey is a little similar to Todd's, but I didn't do too well in electrical engineering. I kept burning the printers every time I have to go to circuits. I will ask the teacher. He had no idea what I was doing wrong. I switched to computers because I was doing electrical and computer engineering at the same time. It was a combined field. So I just did computers, and it was much better. I liked it a lot more. I'm happier with my decision. I worked at Quad Graphics for 11 years, and they were able to sponsor me. So I became a citizen thanks to them. And I became a consultant after that. I've done some apps for Facebook. A friend of mine used to work for RockU, and he said, we can do it ourselves too. So we went into business together. It was really hard. You need a lot of marketing to get your apps working, but we had a few Facebook games. One of them was called Traveling Gnomes, and it reached about 84,000 people at the height, and it started going down. And then we decided to find other jobs. So he went back to California, and I went to work for a power sports company. It was there for maybe 8 years, and then the company closed. Somebody bought the company, and then they redid the software somewhere else. And that's when I ended up going to working as a contractor with Todd and Cody. I did some mobile app for that power sports company, and I like mobile development. So I don't have any clients that do mobile, but I write some for my own. I wrote a little one to keep track of my cryptocurrency. So I just tap, and it tells me how much I made today or how much I lost today. And my wife wanted a little something for when she goes into the baby's room. She didn't want to use the flashlight or turn off the light. So I wrote a little one that it gives her different colors, lights that she can use, and it's not as bright, so she can look around the room before she drops something. And I'm in the process of writing a little game for my 2-year-old now. He likes matching games, but the ones they have are they get too complicated after a while, and then he gets frustrated. So I'm gonna do a simple one for him.
Alrighty, if anyone has any questions, feel free to chime in. Otherwise, we're going to talk about different projects that we've worked on.
One question that we had was, could you explain sort of the difference between electrical engineering and computer engineering? Just kind of a brief, if possible, difference.
Computer electrical engineering deals with the circuits, the resistors, capacitors, transistors, and then you design the circuits. Computer science is the programming of the computer. So let's say the way they are related is you need a computer. So electrical engineering, you design the circuits and you can come up with your computer and the disk drive, hard drive, the mouse, all that has a little bit of electrical engineering in it. Even your car has electrical engineering circuits in them. And then the computer engineering, at least, well, computer engineering is designing circuits for computers. Computer science will be programming those circuits. So once you have the circuits, you need to give it some brains so they know what to do. So you use computer science and write the programs for them. Computer science also applies outside of those circuits, like on the web, where you have websites. Those are all computer, those are all developed with computers. You have to store that data. So you have servers to store the data that deals with computer science also. You have all the, your thermostats may have some code in them also, depending on how fancy they are. It's pretty much everywhere. Your phones, you need to, you have electrical engineering circuits in there, plus also software in them to give them to know what to do. It's almost like having a brain would be the electrical engineering part, and all the connections are there, but you need the knowledge so you can think, and the information would be the computer science part. I may not be explaining this too well.
Well, that makes sense. So electrical engineering is kind of like the hardware stuff that you put in the computer or in the device, and the computer science part of it, the software engineering, is the directions that make it work the way you want to work.
You did it in a couple sentences.
Okay, thank you.
Alrighty, so I'll talk about one of the projects I worked on at my first job. It was an urgent care sign-in application, and the whole purpose of the application was to skip the waiting room. So I don't know about anybody, but I don't like waiting in a random waiting room. I'd like to fill out the forms that I don't want to fill out from the comfort of my own home, so I can pet my dog and be like, yep, here's my information, and get the ball rolling. And we built that out using HTML, JavaScript, CSS, and PHP. The first iteration of the application was just kind of a basic one in terms of gather information, display it to the staff at the urgent care facility so they could input it into their systems. But the future iterations actually were early versions of telemedicine, which is when you have a video chat with a doctor and you have the ability to message them as well. And my favorite part of that project was it was a lot of collaboration with the doctors and the front staff during the entire process to figure out what workflows worked for them and what features would be meaningful to solve kind of the underlying problems that they were wanting to solve. Alfredo?
Some of the projects I've worked on vary from interesting to boring. Some of the boring ones were accounting, supporting the accounting department. So you have those 1099 forms, all the accounting software. The year, and at the end of the year, I have to go in a little late when everybody was gone, so we could roll over the books to the next year, make sure nobody was there adding new stuff, and keep everything ready for accounting. So that's some of the boring stuff. Some of the interesting stuff has been some navigation software for a helicopter. I think it was the same company where Todd did that other software for that helicopter. It was all JavaScript with some framework called Electron that allows you to write JavaScript code, and it turns into a executable on your for Windows. So you can run JavaScript as if it was an executable or from any other language. I've also worked at FedEx SmartPost, helping with the routing of packages. There was a new project. They wanted to send packages to Canada. At the time, the exchange rate was really good, so they were expecting a lot of Canadian customers buying packages from here. So that involved the whole process, learning how everything works. A lot of times in computer science, you don't just do coding, you have to learn a lot of how the process works, and then you know how to what's needed to accomplish the whole task. So that deal with everything. The labels on the boxes, they have to be you have to modify the code so they can handle the Canadian Postal Office labels. You have to work with the Canadian Postal Office, so you know what the requirements are. They know we're going to be injecting these packages into their system and all that stuff. That was kind of fun. Another project has been, I started that business with a friend. We were doing Facebook apps for a while, MySpace apps actually also. That's how long ago it was. MySpace was really bad because all the JavaScript was running on your page. So if you have JavaScript, you will be competing with other people's JavaScripts. Very insecure. The Facebook was interesting, but also very hard. That wasn't PHP, and we used some Flash also. That's pretty much when I was migrating from working on in the computers. We sometimes say front end and back end, which sounds funny, but the front end means the user interface that people work with, and the back end is the servers and everything behind that interface to make it work. So I was doing a lot more of the working behind the scenes, not so much of the front end. And after that, I started moving more towards the UI and the of websites, more web development, which helped me get that other project, SmartPost, at the Power Sports. And I've done some mobile apps, which I also enjoy. But once you know how to program, you can do whatever you want, because you can program at home too.
All right, I'll talk a little bit about my projects, but I've got maybe a general comment about all the projects that we do. A lot of the stuff sounds pretty boring, but I like to think that we're serving the user, right? Like, imagine if when you wanted to order something from Amazon, you needed to fill out a paper form and mail it to them. The software is what prevents you from having to do that kind of stuff, so that you can sit on your phone in your bed ordering stuff off Amazon and say, like, search for this. And it's like, you don't type in dog toys and it's like coming up with hamster toys and wasting your time. Like, all the stuff that we build, hopefully it makes people's lives better. Even if it does sound boring to us, we're hopefully preventing people from having to do lots of boring work manually by themselves without computers. So in that spirit, I've been working lately on healthcare systems to help hospitals figure out how to staff properly. Like, that becomes an important problem, right? Like, if you need 6 nurses and somehow you have them all on the other side of the hospital when they're supposed to be in this unit, that's a big problem. Like, that can affect patients. And the hospital also, no surprise, wants to save money. So they don't want to have too many people in one place, especially if they're all getting overtime for 1.5 times their normal wages. So the hospital wants to save money, and they want to have the proper amount of care at the right place. Also, I've been working on some software that also helps the people in the hospital, that make sure that the person who's doing cardiology, working on people's hearts, like, are they actually certified as a cardiologist? Kind of important. So they allow the doctor to submit like, yes, this board of cardiologists sent this paperwork that says that I am actually a cardiologist and I'm not just pretending to be a cardiologist. So it helps them keep track of that kind of information. So that is using C# for the backend server type layer, like holding all that data, responding to the web page. And then the front end that's actually displaying the data to everybody is using JavaScript and TypeScript, which are two languages that tend to be more in the browser. And so one of the other projects that I did was safety documents for machines. Like if you're working at the Coca-Cola bottling plant and you need to shut down the machine that puts all the stuff in bottles because somebody needs to crawl in there and clean something out, how do you lock it down correctly? And they'll have documents with pictures that say, turn this lever, put a lock here, turn off the steam. And again, without that, like it's a safety issue. If somebody crawls in the machine and all of a sudden starts running because it wasn't locked out right, this gives them the ability to save these safety documents and distribute them on the plant floor so that they can properly do their job. One of the interesting technical parts of that was that we wanted to make it so that somebody could take a picture of the machine with their phone easily and then upload that picture and be like, this is the bottling machine, and label all the parts of the diagram that say like, you know, pull this lever, 1, shut off the steam, 2, and that would link to the steps in the document so that they could easily edit it if something changed, and they don't have to go and like edit a specific picture every time and like start from scratch and add 12 arrows to that same picture. So we made a thing that would do all the image processing in the web browser so that they're not having to go out and use like Microsoft Paint or something before they upload it. That's my interesting projects. We're gonna roll. Oh, are there any questions at this point?
So somebody asked about the difference between what you said, front end and back end. I guess you guys can correct me if I'm wrong on this, but the way I like to explain that is like, if you've ever gone to a play or whatever, the stuff that you see is the front end, and all the people in the back that are moving the pieces around and coordinating and making sure that the timing is right, and the you know, if there's like pyrotechnics or whatever that's going off at the right time, that's the back end. That's the stuff that's happening that you don't see. So most of the programming that you guys are doing in this class is back end stuff, and then when you actually run the program, that's the front end stuff. That's what the user sees.
Yeah, in a browser, like the things that show up in the screen on your browser, like Chrome or whatever, that's like the front end stuff. And then the back end is kind of like you said, it's what makes that possible. So we're gonna roll into a little bit of like, what does success look like? I'm gonna talk a little bit non-traditional approaches, more like Cody, like doesn't have like a college background in programming. So a lot of those folks can be really successful, especially now. Like I know very successful people that are like English majors, so they didn't go to college for anything technically related, or people who have been through like a boot camp kind of experience where they did like an 8-week program here in Milwaukee or somewhere else where they kind of got like a accelerated kind of education in a short period of time. Or you know, there's other folks that are just completely self-taught. I think it's a lot easier now to do that sort of thing, and partially it's because people used to think programmers are basically like mathematicians that also know how to write programs. But the math that's required really isn't as much as it used to be in a lot of cases. And there's kind of some things, some programming jobs will require a lot of math and some really won't. So I knew a guy who was working on like radar systems, like how do I make this plane not be detected by radar that well? That required a lot of math. But a lot of the stuff that I've been working on recently is really more like design and like, where should I put this code and what does it need to do? And what does the front end need to look like? And where should this be on the screen so that the user isn't confused as to what's going on? So it doesn't require as much math. It requires more of maybe like the logic part of math, like solving a puzzle. Like if I need this to end up here, then this, and this need to happen. So how can I arrange this in a way that what I want to happen happens? So that's not what I think people think of when they think about math. Like it's not calculus, it's not trigonometry or geometry. It's the logical part. Like if I need these steps to happen, how do I get from A to B? There's also a lot of different roles in programming. Like there's user interface, like the front end stuff, what's shown on the screen, making it look nice and like what they call intuitive, like you can use this page without specific training. It just is natural to you. Leadership within programming, being able to provide those skills. Organization, like we should do this first, then we should do this, then we should do this. That's another role within programming and development. And then there's also what we call quality assurance. Once the project is made, somebody needs to check to see that it works the way that it should. And that's a slightly different skill set usually than writing the code. But it's still a technical job and it still pays like a technical pay scale does. I'm going to leave it at that for that part.
I think some of the stuff that you touched on, Todd, is a good segue into one of the points that I had. Programming isn't a solo job. So you're not going to be in a dark room working by yourself for hours on end and you just ship off your code to somebody and they're like, thanks for the good work. It's really more about collaboration and working together with people. I really like the social aspect of my job because I have to work with people that interact with the customers, or I get to actually speak with the customers themselves and hear how using the software impacts their day-to-day life. So it's being able to marry like soft skills of interacting with people with the ability to really use that mindset that Todd touched on earlier of a certain way of thinking to deliver a meaningful solution to their problems. All right. Go ahead, Alfredo.
Something I wanted to make students aware also. I think Touch mentioned it. Sometimes it's almost like solving puzzles, like Todd mentioned. There are a lot of so if you like puzzles, this is going to be a good job because there's a lot of logical puzzles to be solved when you're coding. Also, the field changes very, very fast, so you will not get bored. There's always something new coming. When I started, it was on what we call client server machines. You coded on a client machine and you went to the server. Then personal computers came in and then we were programming in Visual Basic. Then C# came out and then we started programming in C#. And now the internet became much better and faster. We started doing things in JavaScript. And in JavaScript, you have a bunch of different frameworks like Angular, React, Vue now. So it's almost like every 2 years, there's a new framework coming out. And then mobile phones came out, and then everybody was programming for mobile phones. And then suddenly there's websites that want to have apps that they become super popular. So Facebook, now you can program for Facebook apps. So you have mobile phones, VR is coming up, becoming more popular. So pretty soon you're gonna have to code for VR. Everything's becoming more computerized. So your cars have more electronics and computer systems in them. So you probably have to code for cars also. Everything is like pretty much everything's got computers now more than before, and it seems like it's more and more. In the old days, I'll pick up a piece of paper and I'll read it. Now I have to pick up a piece of electronics to read stuff. Like I can read on my phone. There's a Kindle to read. So things that you didn't think would become computer programmed have become programmed, like records. And music was stored in a thing, and then it was all electrical, and then something will spin around and capture the sound and you hear it. But now it's all computerized. The songs are in computer code, and then you have code to play it back for you. So it's changing. It's everywhere, and I feel like it makes me understand things a little better than some relatives that don't are not into computers. I know how the TV will probably work, or how to program the TV, or the Wi-Fi goes out. You kind of have a better sense of how to fix your problems, or something with your phone. You know how it works. Websites, it's everywhere, and I think it's necessary to at least be familiar with it. And you have to keep learning constantly. There's constant learning.
Have any of you ever had a project where like the user wanted something that you just could not deliver?
I've been in a situation where they asked for something and I would not deliver it to them, because there are times when people with the best intentions will want a feature that doesn't really make sense. So you know how when you click on a page and you right click and it gives you that little menu that says copy, paste, or different things that you can interact with on the page? They're like, we want that to be disabled. And they didn't really have a good reason for that. And it took a lot of pushback and conversation to get to a mutual level of understanding to like why they wanted that and why it wasn't necessarily a good idea to program against like default expected behaviors.
There are
So
many
like,
things.
I don't mean to dig too much into that, but like they just had some proprietary stuff on their site that they didn't want copied.
I don't know, to be honest, because it was a while back and I'm having difficulty recalling the specifics, but it was for orthopedic clinic and everything was public information. So it didn't really make a whole lot of sense.
It's ethics in programming. Good.
Yep.
Sometimes there are certain things that are almost impossible to program, I guess you could say. So, but the people that come up with the project, they kind of know, and if they don't know, they'll find out and then they'll adjust the project. For example, one thing that comes up very frequently is speed. They may have a form or a process that the user enters information and it takes maybe a few seconds, and they say, we want to cut it down to a few milliseconds. It's like, it's going to be really hard because the information has to travel at a certain speed to your server. And then if you have too much data, you have to, depends on what you're doing behind it. If you are validating the form, that takes some time. So there are certain limits. So it's not like we can do anything we want. Yes, there are limits.
It's also worth mentioning too, I would say that nothing isn't possible. There's just always going to be a trade-off of it's either going to take more time, or it's going to take better hardware, or it's going to take research to figure out how to do something that's never been done before. So it just depends on what the business is okay with making the trade-off for.
One other question. This is from me. Right now, my students are learning Java, which you guys know is different from JavaScript. But if you guys aren't aware of that, JavaScript is a language that's used mostly on websites, whereas Java is used mostly for like standalone applications that you would run outside of, like on a computer. Is there something that you think high school students should be learning if they're interested, like a language or a concept or anything that you think it's like, this isn't that bad of a concept and it's really important in my job?
Good question.
For me, one thing that I learned when I was studying was object-oriented programming. And at the time they talk about inheritance. So this is a while ago. So everything's like inherited. So we have a class inherits from this class and from this class, but that's not the recommended way of doing things. Now they recommend composition. And you can notice at the time, if you inherit too much, things get too tightly coupled and it gets a little, you change something, it's hard because everything inherits from that. So there's a lot of changes propagating. It's good and bad because sometimes you want those changes to propagate. It's bad if it's like requires a lot of tweaking later on. So composition, it's almost like you say you want to use, you want to log your data, for example. So all you know is I want to log it. So you tell a program, the class that you're writing, okay, here's your logger, but you don't care where it's logging. So you use it. Okay, I'm logging this. Boop, that's it. And then what you write, the part that you're inheriting from, no, that you're not inheriting, the part that you are, well, I guess it's almost like an inheritance, that you are injecting into your class, that the logger could log to, could display it on a screen, it could print it, it could maybe send an email, but your class shouldn't care. So that's pretty much the concept that we use a lot nowadays, where it's called interfaces. I think JavaScript, Java also has interfaces. So we use interfaces a lot to pass the behaviors we want. So that's the more recommended thing. That at the time when I was learning, it was more inheritance, but now it's more composition or using interfaces. Your teacher can probably show you that. He's pretty good explaining, because as I've noticed.
For maybe an example of like an interface, like an outlet in your house is like an interface. Like you can plug in a heater, you can plug in a light, you can plug in a hair dryer. The agreement is that if you plug these two things in, you'll get 115 volts. And we don't care from there, like what you do with them. But it makes it so you can mix and match pieces together as long as they're both saying, hey, I am a normal wall outlet. Hey, I am a thing that needs normal wall outlet power.
Tom, to answer your question, from my perspective, I would say what you should learn is figure out, and this applies to really whatever industry you go into, figure out how you like to learn. If you like audiobooks, if you like to read, if you're more of a hands-on person that likes personal projects, because that'll really be beneficial regardless of where you end up. I really like to read books, and I'm a hands-on person. Audiobooks and video formats can be useful for me, but they're kind of draining. But being able to figure out a way that I enjoy learning has made it so when I have to spend the time to get up to speed on something, or I'm just doing it for fun, that it's a leisurely activity that isn't really a stressor for me.
Are we open to questions, or is there another part of the presentation?
No, I think we're good for questions.
Do you guys have any questions that have been sparked? So I guess if I can ask a follow-up question to the other one, is there like, not so necessarily, and Cody, you kind of did this, but not necessarily like a programming concept, but if, let's say that a student has an idea for an app that they want to build, or has an idea for an invention and they want to know like, what, I have this idea, but I don't know how to, make it happen or whatever. I guess what I'm wondering is like, what part of programming, or I don't know, I'm having a hard time formulating my question even, I guess. Like, we don't do anything with CSS in my class. We don't do anything with like PHP. We don't do anything like, we're not worried about a server or anything like that. Is there anything that you look at and you're like, well, this is something you really should learn in high school because you need to know it?
Something I
Well, I'm just gonna jump in while they're thinking. I was a finance major, so I happened to, just because my dad basically said, hey, you should take accounting in high school. And by me taking accounting in high school, just made my college experience so much easier. And then I eventually went into finance, not accounting, but finance. And that was like the best advice ever. Because if I hadn't gotten that out of the way, I wouldn't have understood that I liked finance. Plus, I was able to breeze through accounting in college, where my friends that had never been introduced struggled. And then it really negatively affected how they felt. And they didn't want to go into anything like accounting or finance. So that's kind of an example from a different industry. Is there anything, if that helps the rest of the team, that you would recommend for the students?
Yeah, I feel like a introduction into web development is really something that a lot of people would benefit from, because it teaches you that what's displaying the Amazon page in front of you is complicated, but at the same time, the building blocks that make it up are pretty simple, and you could build your own little web page within a few hours if you wanted to. And that's HTML, CSS, and JavaScript is what would give you that.
and it's all free. You can just do it on your home computer right now. Just put it on your desktop, write the program, open it on your browser. It's yeah, it's very simple. All the tools nowadays are pretty much free.
It's pretty easy to find a project that can spark your interest or be similar to, if you have a dream, I guess, of something that you'd like to make, you can find a similar project and then get that going, and just try and get something simple. Like, don't try and write 10,000 lines of code that you won't see any result from, like write 100 lines of code and see a little, on and off little circle appearing on the screen. You'll be like, I'm a genius. It can be very inspiring just to see a little piece of your code working.
If you like video games, I would recommend you can maybe learn Unity or Unreal Engine. Those are game engines. I'm learning Unity on my own at home because I think you can write games for your PC or for any other console device, and also you can use it to write mobile games, which is what I want to use it for. It's I'm also using it for non-games, which you can do. But you have to make it more optimal. You turn off the game engine part of it. There's videos that show you how to do those things. It's not really, it's a bit hard at the beginning because the interface is a little complicated, but once you get used to it, it's super easy.
So I know, Tom, we're kind of getting near the end of the time, but just real quickly, just a couple things that I heard, just to summarize, as far as maybe some skills that are needed, or, if you're strong in this. I heard a lot of things about, working well with others. So collaboration. I heard a lot about needing to be able to, ask questions and listen, and then have the logic to be able to problem solve and solve the problem that the client has. I heard that, programming takes, creative skills. Math is a plus, but, as Todd mentioned, it's not as heavy maybe as it used to be. And then just somebody that, really likes to continuously learn, because this is a fast-paced, field, and there's constantly new concepts and software coming out. So somebody that is not, that enjoys that and that likes to, learn and keep their skills up. Did I miss anything?
I think that summarizes it well.
Really good, actually.
Well, I want to say thank you very much for coming in and talking to us today. Sorry we didn't get to see the students. It makes it a little bit impersonal, but they were all attentive and interested. So thank you very much for that. Let's give them a round of applause.
And thank you so much, Tom, for letting us come into the classroom virtually. Also, we'll just open up to if there's any questions for follow-up that the students come to you with. Tom, just send me an email and we'll get those answers and back to you if there's some additional questions that come up after this.
Great. Sounds good.
Okay,
Thank you
great.
so much.
Thank you, everyone, for your
Thanks,
time.
everybody.
Thank you.